More Thomas the Tank Engine stuff. I've looked before at my red engine, which has got two things called reed switches, glass tubes with bits of metal inside that come together when they're over a magnet. You can put them on my track, which has got magnets at each end. So if I switch it on, put it on top of the track, it belts backwards and forwards but doesn't stop at the ends. So the problem is it's going to burn out the relay. It really needs to stop. So to do that, I've modified another Thomas. This Thomas then has a delay inside it, so that when it starts going, it goes to the magnet and stops for 6 seconds, goes to the other magnet and stops for 6 seconds, or if it's disturbed 12 seconds, and then it goes off backwards and forwards quite happily, trundling along with a delay at each end, so it ain't gonna ruin the relay, hopefully anyway. So how have I done it? Well, one of the things I wanted to do instead of using the reed switches was to use things called Hall effect switches. Now these are an electronic device with a magnifier inside, which work on the basis that little electrons travelling through the device will be moved to one side by a magnet, and that then is amplified and sent out as a signal. Bit difficult to see what I've done on this particular version because I've covered it all over with what, hot melt glue or whatever you call it. So here, let's try and look at this, see if this is any good. What we've got is a Hall switch here, 3 leads coming out, the 0 volts goes straight out, and the positive goes straight out, but has soldered across the other side of it a resistor. So we've got a resistor between the output and the positive, or between the positive and output, since we've switched it the other way around. The top now is positive, this is the output. We've got a resistor on here, and so that we can amplify the signal to drive the relays from the Hall effect device, which can only handle about 20 milliamps. Then I've just put on here a little P-type FET, soldered it on so that the output from the FET, which is this middle leg here, can be used as a switch. So the output from the Hall effect only goes into the FET and no further, and the output from the FET then is the one that I'm using to switch the relay. Perhaps a little diagram would help. So here is a diagram of what's going on. We have our Hall switch, 3 outputs, positive, 0 volts and switch. So across positive and switch I've soldered a 10k resistor, and then a P-type FET, so that the output only goes to the FET, the 0 volts doesn't go to anything but straight out, and the positive goes to this end of the resistor and to this leg of the FET. If we draw a little diagram then maybe this will help. We have our Hall effect sensor here, which has a little transistor inside it, only 20 milliamps. That output then needs pulling high, so I've got a 10k resistor, and then I've got a bad drawing of a FET. So this gives us an inverted output. This would normally go low, so this now goes high. And these beautiful little FETs, they're 4 amps or something silly. but I don't need anything like that. That then sends the signal out. For the rest of the circuit, I need to be able to put on a delay. One way of putting a delay on is to have the FET driving my coil of my relay. I'm using a latching relay, so it has two coils. One coil pulls it in one direction, the other pulls it in the other. And then I could send it, to get a pulse, send it through a capacitor with resistors either side. That then gives me a pulse. And to get the delay on the output, I've used an N-type FET, which drives the relay, which is a changeover relay. So one coil pulls it one way, the other coil pulls it the other way. And this capacitor down here then is my timing capacitor, so that when this transistor switches on, it short circuits the capacitor, taking it down to 0, and then through this 1 meg resistor the capacitor slowly charges up. Of course, if I wanted it to be quicker, I could have used a smaller capacitor or resistor, but the 6 seconds seems about right. So where to go from there? Well, at this particular setup, each relay, of course, I have two Hall effect switches, so I have a second one coming in here, and so it acts as an OR gate. I've put a couple of diodes in so that the signal from this one can't affect that one, and the signal from this one can't affect that one. But I didn't like the idea that the switch would be powered all the time. The magnet was on for the 6 seconds, so I went to a different solution, and that solution was to put the delay actually on the Hall effect switch. So instead of just coming straight out into the transistor, I put a capacitor across the output of the Hall effect switch. That then, the 0 volt still comes straight out. The capacitor then has a 10k at this side and a 10k at that side, and then feeds into my FET. So here we have it, the other side, capacitor, resistor, pull-up resistor, timing capacitor, Hall effect, pull-up resistor, timing capacitor, reset resistor for the capacitor. Then we have the FET device. So if we look at that again on our diagram, what we've got is just the same as before with the Hall effect, 10k, 10k pulling the output high, but then I've put my 1 microfarad capacitor in here, and then another resistor on this side so that the capacitor can discharge, and the FET just the same down here with the output coming out. So we've got our 0 volts, 5 volts, and the yellow is coming out. If we look at the circuit then, what we get is Hall, 10k pull up, pulse capacitor pulled high by the 10k, and that once again going into the p-type FET, and this then just gives us a pulsed output. We did lots of trials of this. Lots of simulations, tried the capacitors in different places, but came to the conclusion that the best circuit was to have the Hall effect here, which is represented by a push button. This is the pull-up resistor, which isn't actually in the Hall effect, but is part of the pulse producing part. That then feeds into my FET, p-type FET, and then that FET drives the relay and the diode, which forms the OR gate, which goes through a 10k resistor into this capacitor to short this transistor to short this capacitor, which then switches off the FET for a set period of time, 6 seconds it seems in this case. So the motor stops, and once this capacitor is timed out, then the relays have been swapped over, so therefore the motor starts again, but going in the opposite direction. If we look at the voltage on here as a red line, and then we look at the voltage here from the output from the Hall effect as blue line, what we find is that the motor's on all the way up. The Hall effect triggers a very small pulse. The timing here is about 1.82, so it's about 0.2 of a second while they have this pulse. It then goes off, and then the timing capacitor starts to charge again. Really chuffed with that. I think it's alright. I'm not so chuffed with the way I built it though. If we have a look at that, I had a lot of modifications to do, a lot of playing about. Took a long time to get it to operate. Getting the values right, getting it so it would work, and also fitting it inside the engine. I've got my 2 wires here going off to the light I've put on the front. Not too sure if I can get rid of those, never mind. The relay itself, which is hidden somewhere at the back here, did it on a piece of Veriboard. Got my relay at the back. I've had to cut away the whole of the back of the engine. Don't know if we can see that. Cut away the whole of the back so that I can get my little circuit board in. I've used surface mounted diodes for the OR gate and across the coil of the relay so that there's no sort of back EMF. Got another diodes here. There's 2 of the OR gates. Those 2 are across the relay. And I've a diode here which goes across the motor. I've got the crossover wires, the blue and green here, and the positive and switch wire coming in to the controls on the relay. And up at this end I've got my switch, my on-off switch, which has got the timing capacitors on the underside with a transistor here. Don't know if we can see that. Transistor there, through hole transistor, just a Darlington 517, BC 517 to short the capacitor out. Put the cells in, normal cells in, but for the relay I needed 5 volts, so I've just put a little boost board on the front here. Then this is supposed to boost anything from 0.9 volts up to 5 volts, so it works reasonably well for operating my relay. So that then is my reversing train with delay. I think that's all I want to say about it. I think I've covered it all more or less. I've covered the Hall effect switches, I've covered the booster board, covered the circuit at the back. Just look at that once again. So what we've got is the diode across the motor, the N-type FET here, which is a surface mounted FET on the Veriboard. Don't know if we can see that or not. It's very small, of course, surface mount, difficult to see. Yeah, maybe it's just come into focus. There then is the surface mounted FET, and over here we've got some small resistors. We've got a capacitor. I did try putting a capacitor across. Oh, that's what one of these capacitors is, to try and smooth out the input voltage. Don't know if it was needed or not, but I've put it in anyway. Yep, I've spent an awful long time on that. It's a great mess. Maybe I could build a better version using a printed circuit board. But hey, it works. It proves the point, which is all I really want to do. And now I can move on and see if I can remotely control a Thomas. I've taken away a lot of the bottom. I was having the Hall effect switches here, but found it didn't work because the motor's at the other side here, and that affected the Hall effect switches. So I've had to move them up to here, out of the way of the motor. Right then, I think that'll do for now. So it's bye now. Bye.